So hello everyone, a very good afternoon to all of you, and I Prakhar Shrivastava welcome you to this brand new, you can say, topic, that is non-traditional machining process. So as I have promised, I will be covering up this part of non-traditional machining process in upcoming 5-6 lectures. So today I am going to give you a brief idea about what is non-traditional process, why the concept of non-traditional process came into existence, what are the different techniques that we use in non-traditional machining process. Slowly, I will make you feel what non-traditional machining is and how to solve questions related to non-traditional machining. Okay, you will feel that what non-traditional machining process is. And believe me, if you see previous 10-year papers, whatever I am teaching you, 100% of the paper is almost, you can say, hardly one question in on an average, one question per year is something that is out of something that I taught you. Okay, तो जो भी मैं पढ़ा रहा हूँ, whatever I am teaching you, that is currently getting or exactly getting replicated in the final paper. I am not saying this that I am doing this, I am doing that. No, I am just telling this to make you believe that yes, you can do it. Okay, you can solve manufacturing all 10 or 11 questions from manufacturing directly. I hope that I am audible and visible to all of you. Just a second, let me check. Second, let me check it that whether it is working or not. Okay, I think that it's working fine. I think that it's working fine. So why so less people today यार? पता नहीं रहता क्या? Daily I actually start late about like 2:45, so that is why people might be joining at 2:45. It might be possible, ठीक है? Otherwise these videos are always available. देखो live lecture में फायदा ये रहता है that you are actually along with the faculty, you can complete the entire syllabus without any difficulty. But when you are seeing this in the recorded format, it becomes difficult for you to cover up the entire syllabus. Okay, chalo. We'll wait for like 2 to 3 minutes for other people to join. By the time, if you are having any doubt, you can throw your doubt right now, right here, because today we are going to start with the entirely new topic of non-traditional machining. Every year we have seen a question from non-traditional machining, and the level of question that you actually get from non-traditional machining is quite easy. Okay, so it is quite easy. You don't have to worry about that. Whatever, dekho, one very important thing is this, that you have to study what is required from exam perspective. You don't have to study what the coachings are telling you. You don't have to read the entire books. You are not doing PhD or masters. You have to follow a particular pattern that is required from GATE perspective. Is it clear? So that is why I always teach less, so that you can revise. Without revision, nobody is going to crack the exam. So that is why revision is very important. Revision is very important for you. And if revision is important, then you have to revise constantly. Now, to revise constantly or consistently, your syllabus should be less. Okay, your content should be less. You cannot study this much, then revise this much, then again revise this much. This is not possible actually. Okay, this is not possible actually. So don't run behind a lot of content. Don't run behind on a lot of content. Whatever I'm giving you in manufacturing and industrial, that is more than enough, more than sufficient for you to cover up the syllabus, more than sufficient for you to crack the exam. And if you see previous 10-year papers, you will get to know that whatever I am teaching you in these 100 hours, you can say that is more than enough. That is literally more than enough. Have faith in your faculty. I'll make you crack. Okay, chalo. So thank you all for your love and support. I'll just give a brief introduction about me. Okay. My name is Prakhar Shrivastava. I have secured All India third rank in GATE 2016. Then I took admission into IIT Bombay and finally completed my masters from NITI Mumbai. From past 3 years I'm teaching, and yes, I'm having approximately 22,000 followers on Unacademy. So thank you all for your love and support. Okay, I wish that I could help you out in your exam preparation. I'm doing my best. I'm providing you with the content. I'm providing you with the motivation. I'm providing with you to you with the feeling of what subject is. With the feeling of what subject is. Okay. Good evening, everyone. Good evening. Good evening. Good evening. Yes. इसके बाद metrology start होगा. ठीक है. So that is one very important thing. Secondly, the subjects that I deal with is industrial engineering, manufacturing technology, and engineering mathematics. Okay. Chalo. So let me tell you something about the Plus subscription. Who are seeing this for the first time, I don't know. because most of the faculty use this slide, so you might be aware about it. Plus subscription is just another platform, okay, where you can get the education, but it is a paid platform, because you are going to get live classes, crash course. To practice, you will be getting rank improvement badge. You can monitor your growth by like enrolling into the weekly tests, doubt clearing session after every third lecture. Both of them, everything of them will be happening in English and Hindi. Now there is one more offering for you people, that is iconic subscription, where you will be getting one personal coach for you. एक coach आप पे dedicated रहेगा, who will guide you, motivate you, make you prepare, keeps you up for the exam, like constantly give you information regarding the examination. So a personal coach will be given, study material will be given. You don't have to go anywhere else. कोई telegram नहीं, कोई YouTube नहीं, इधर उधर. Don't waste time. Sit back, study from iconic subscription or plus subscription, and study the study study material, and just prepare from the study material. ठीक है, चलो. A plan will be given to you, that is the timetable that you need to follow to crack the exam. Personalized test analysis. I particularly like this feature a lot, because you have to give test and you will be giving test. You have to give test and you will be giving test. But more importantly, you should analyze what are your weak areas. You should analyze where you are not actually like doing the things that are required to crack the exam. What are the areas where you need to improve? And this analysis is much more important. Just giving the test is not important. Test is not only for knowledge, it is for time management, it is for your personal development, it is to make you exam ready. And when you become exam ready, when you know your weaknesses, okay. So I hope that this is crystal clear to you. What are the charges? If you apply the code crack10, if you apply the code crack10, just remember this code crack10, CRACK10, okay, then you would be getting approximately 20, you have to pay 27,225 rupees for 1 year, 34,650 rupees for 18 months, and 39,600 rupees for 24 months. 39,600 rupees for 24 months. And what are the charges? What are the charges for what are the charges for this thing, that is iconic subscription? This is my another code, Prakhar21. You can use this code Prakhar21 also, not a very big deal. Now for iconic subscription, for 1 year you have to pay 45,225 rupees, and for 2 years you need to pay 66,600 rupees. 66,600 rupees. Okay. And there is an important announcement. I have started this industrial revision module, where I will be teaching you 43 important topics. And believe me, these topics in past 10 years, all the questions in industrial engineering have been from these 43 topics only. कोई दिक्कत लेने की बात नहीं है. Don't take load of industrial engineering and manufacturing. That is on me. Just attend the lecture live. Just start attending the lectures live. Just start attending the lectures live. That is all you need to do. That is actually what you all need to do. Okay, don't forget to subscribe. Don't forget to go on my profile on Unacademy. Just write Prakhar Shrivastava Unacademy on Google. My profile will open. You can see the special class over there. Okay, and I have shared the link on the various Telegram channel as well. The Telegram channel, official Telegram channel, that is Unacademy GATE ME. ठीक है, जो official Telegram channel है, on that also I have shared. Do hit the button, enroll yourself, so that you will be getting some really beautiful concepts related to the industrial introduction. For industrial introduction in India, you don't have to go anywhere else. Whatever I am teaching you, the questions are from my notes. The practice series that I am giving is more than enough. Then why you need to study extra? You don't have to study extra. You have to study very less. Revise, practice. Okay. So I hope now you are ready for this new topic on non-traditional machining process. Non-traditional machining operation. Now, why do you think that non-traditional machining is required? I am already doing the cutting part. I am already doing the cutting. Why this cutting cannot be done in certain cases? Why this cutting cannot be done in certain cases, and what is the use of some other machining process? I don't know what that machining process is. I don't know what that machining process is. But I want your answer. That why do you think that we require some different kind of machining process? Why do you think that we require some different kind of machining process? Requirement. Quickly, I want some answers. I really want some answers. Good afternoon, everyone. Good afternoon. Jaldi se batao. Why do you think that non-traditional machining process is required? Why we cannot do certain things? Why we cannot do certain things from the normal machining process? Why we cannot do it? Why we cannot do it? Jaldi batao. Quickly. Good evening, everyone. Good evening. Now, answer my question. Why do you think that non-traditional machining operation is required? I can do metal cutting. But why do you think that there is an issue in cutting? Why do you think that there is an issue? Very good. Better surface finish. Better surface finish. Please make notes along with me, guys. Please make notes along with me. And accuracy. Good. Second, what can be another reason? What can be higher production rate is okay, that we can get in machining also. What all do you think? Dekho, many a times your workpiece is so hard that your tool actually breaks while machining. When your workpiece is very hard, you cannot use any tool. In fact, diamond also you cannot use because it is mixed. Yes or no? Pure diamond you don't have. So that is why if a material is an alloy and it is very hard, can you do machining? No. Due to forces, it will cut, because when you do machining out of tool and workpiece, one which is lighter or which is, you can say, have less strength, it breaks. So if the workpiece is heavy, workpiece is very hard, the tool gets engaged and tool breaks. So is my machining done? No, my machining is not done. Okay, no, my machining is not done. So that is why in case of very hard component, or in case of you can say hard or strong material, non-traditional machining is done. Sir, इसमें भी तो tool होगा. Sir, in non-traditional machining also we have tool. Then what is the issue? See, very important, guys, very important. In non-traditional machining operation, there is no contact between the tool and the workpiece. If there is no contact between the tool and the workpiece, then what is the use of hardness? What is the hardness? Does hardness really matters? If there is no interaction between the tool and the workpiece? No, it doesn't matter. How hard is material? I don't care. In non-traditional machining operation, there is no contact between the tool and the workpiece. Since there is no contact between the tool and the workpiece, do you think hardness of workpiece matter? No, it doesn't matter. Okay? So that is why for machining, hard and strong components, you will slowly you will understand what is non-traditional machining. Traditional machining is cutting like this. Traditional machining is drilling. Traditional machining is grinding. But non-traditional machining operation is a machining operation. That is, it is a metal removal operation. But there is no direct contact between the tool and the workpiece. I hope you understand this. Clear enough? So that is one very important reason. When the workpiece is hard and strong, you cannot use the traditional machining operation, and hence you have to use non-traditional machining operation. Okay? Start feeling the topic. Because if you cannot feel the topic, you cannot solve the question. Because I always say, feel the topic so that you can make questions in the exam. You can actually find the solution in the exam. If you are conceptually clear and feel the topic, you don't require to study much. You study what is required. Revision, practice. That's why I try to convey the feeling from here to there. Okay, that is why I try to convey feeling from here to there. Okay, you don't have to study much. This much you don't have to study. You have to study this much only, what is required from the exam perspective. but this should be crystal clear in your head and crystal clear in your heart. Do you understand that? Give the third point. Now, any other reason? Any other reason? Any other reason? फटाफट बताओ. It is not possible. It is not possible. It is not possible. It is not possible. What is not? The direct contact between the tool and the workpiece. Now suppose hole is somewhere inside. How can you put your drill inside and drill the hole? It is not possible now. So what you will do? You will put a chemical, and due to chemical the drilling will happen. Can you feel it? Now suppose I want to do the drilling somewhere here in this part. Now it is not possible for me to go inside and drill it. I cannot do that. But yes, I can pour the liquid metal, I can pour the chemical, and I can drill it inside. I can drill it inside. Now there is no direct contact between the tool and the workpiece. Only the chemical is applied and drilling or hole making is done. This is non-traditional way of doing machining. This is non-traditional way of doing machining. Is it clear? Shubhra here, thank you. That is a great point. That is again a very good point. That is heat affected zone is less, but advantages we will see separately. The advantages of non-traditional machining we will see separately. Is it clear? That we will see separately. Here we are understanding why there is a use, why the concept of non-traditional machining came in. If you have liked the video till now, jaldi se like thok do. Fatafat hit the like button if you have really liked the video till now. If you have liked the video till now, please hit the like button right now, right now. Clear? Now, it is not possible the direct contact between tool and workpiece. Between tool and workpiece. Between tool and workpiece, it is not possible. Okay? Between tool and workpiece, it is not possible to cut. Although the cost will increase in non-traditional machining process. The cost will increase in non-traditional machining operation. But since I cannot do the machining because contact ही नहीं हो पा रहा है, I have to use non-traditional machining operation because there is no other way out. There is no other way out. Is it clear? Is it clear? This is very, very important. So I hope you are crystal clear with this part. You are crystal clear with this part. You are crystal clear with this part that why we are going or why we are studying non-traditional machining operation. Why we are studying non-traditional machining operation. ठीक है? इसके अलावा when the workpiece material is very highly brittle, अगर आपका वर्कपीस मटेरियल बहुत ज्यादा डेलिकेट है, can you apply force? Can you do that? No, you cannot do that. If your workpiece material is delicate, if your workpiece material is brittle, you cannot apply the force with the help of tool. You cannot apply the force with the help of tool. It will break. So that is why there we require some machining operation such that the tool is not touching the workpiece. The tool is not touching the workpiece. The tool is not touching the workpiece. So this is another reason. When your workpiece material is delicate or brittle, please make notes along with me. You will really enjoy. I'm telling you, my notes more than enough to crack the exam. But you have to make notes. You have to revise them. You have to practice questions. Is it clear? Is this thing clear? Now, now, suppose complex shape needs to be made. Complex shape needs to be made. Needs to be made. Now, if you actually see this thing, that suppose you need to make this shape. This is the casting that you need to make. This is gun. This is Kaleen Bhaiya ki gun. ठीक है. नाउ इफ यू नीड टू मेक कालीन भैया की गन, if you actually need to make कालीन भैया की gun, you cannot do it with machining operation. This here and there, here and there, here and there. You cannot make it directly. You cannot make it with the help of direct machining operation. You cannot make it with the help of direct machining operation. You cannot make it with the help of direct machining operation. Is it clear? So that is why you require chemical to dissolve this part. You actually require chemical to dissolve this red part. You actually require chemical to dissolve these vacant spaces. Is it clear? To dissolve these parts, it is not that easy to make. It is not that easy to make. It is not that easy to make. So that is why you cannot make complex shape with the help of normal machining operation. Normal metal cutting से you cannot make complex shapes. You cannot make complex shapes. Yes or no? Give the heading. When लिख लिया था क्या? हाँ, complex shape need to be made. When complex shape need to be made, you require non-traditional machining operation. You actually require non-traditional machining operation. Is this thing clear to all of you? I literally want to listen to your answer. ठीक है, listen to your answer. Is it clear? So now you have to understand types of non-traditional machining operation. You need to do machining. Yes or no? Machining तो हो ही रही है. So if you need to do machining, normally you are not cutting it, but you require energy to cut. Yes or no? You require energy to cut. You have to give energy to cut. You have to apply energy to cut. इंडस्ट्रियल की क्लास 6 PM पे है. The industrial class is on 6 PM. The industrial class is at 6 PM. Now, energy is required. Now, depending on the source of energy, the process is divided. Whether it is a chemical energy, whether it is a electricity plus chemical, or you can say electrochemical energy, whether it is a mechanical energy, whether it is a thermal energy. So there are various type of energy used for machining. There are various type of energy that is used for machining. There are various type of energy that is used for machining. So machining के लिए energy is required, but depending upon the type or depending on the way in which we are supplying energy, types of NTM operation is divided. Types of NTM operation is divided. Please make notes along with me. Energy तो लगेगी ना. If you need to machine a operation or machine a particular product, don't you think that energy is required? Energy is there. While cutting, we are giving the mechanical energy. Drilling is a mechanical energy. Milling, grinding. But here, there can be other type of energy as well. That is mechanical energy, thermal energy, chemical energy, electrical energy, electrochemical energy, nuclear energy. Any energy can be there. Energy can be supplied in various format. Now, depending यार actually अश्विन, ये तो कहीं ना कहीं क्लैश होगा. From 6 or rather from tomorrow I will keep it at 5. From 5 we can have the industrial revision, 5 to 7 PM. 5 to 7 PM we can have industrial revision from tomorrow. Today it will be at 6 only. Today it will be at 6 only. So yes, I was telling, depending upon the energy used for machining, types of NTM operation is divided. ठीक है, लिख लो. सबसे पहले लिखो operation that we need to understand. Mechanical, thermal. These are two important source of energy. ठीक है. Abrasive jet machining. You write completely. Abrasive jet machining. Water jet machining. water jet machining, ultrasonic machining, ultrasonic machining. These are the three mechanical operations that we need to study. Now, what is, देखो, अच्छा, can anybody tell me while we are actually cutting the workpiece, what is the mechanism? What is the mechanism? Star mark करके लिखो. The mechanism of material removal. Mechanism of material removal in conventional cutting is shear, plastic shear, is plastic shear. Due to plastic shear, cutting is taking place. Due to plastic shear, cutting was taking place in normal cutting operation. We have seen tau s. हमने ये सब पढ़ा है ना? We have already discussed this. Yes or no? Yes or no? So plastic shear is the reason, is the mechanism. Mechanism बोलते हैं इसको, mechanism. Remember it. So what is the mechanism in mechanical? So please write mechanism. In this case is erosion. Mechanism in this case is erosion. Mechanism in this case is erosion. Mechanism in this case is erosion. Now what are the process you need to study in thermal? EDM, most important, electro discharge machining. Please make note along with me. EDM, electro discharge machining. EBM, electron beam machining. Electron beam machining. Electron beam machining. LBM, laser beam machining. Laser beam machining. Laser beam machining. IBM, ion beam machining. All these processes we have to study. Ion beam machining. Ion beam machining. And fifth is PAM, plasma arc machining. Plasma arc machining. Plasma arc machining. Is it clear? Now, this is the first type, second type. There will be a third type. I hope you have noted it down. It's one and the same thing. You don't have to worry about that. Karthikeyan, you don't have to actually worry about that. If I give you the knowledge of what abrasive jet machining, it's one and the same thing. Here in abrasive jet machining, you have abrasives also. In water jet machining, only water is there. Okay, then. Third, mechanical, thermal, chemical. केमिकल, ठीक है. ड्यू टू मैकेनिज्म क्या होता है केमिकल में? मैकेनिज्म क्या होता है? कोरोजन. कोरोजन, आई हैव गिवन यू एन एग्जांपल. इफ आई वांट टू डू अ होल, इफ आई वांट टू, थर्मल के लिए बता रहा हूं, रुक जाओ. If I want to do a hole, I'll apply the liquid, that is the chemical, it will go inside and do the hole. So that is why the mechanism for chemical is hole. Mechanism for chemical is corrosion. The mechanical, क्या बोल रहा हूँ? The mechanism for chemical is corrosion. And the fourth is electrochemical machining. Electrochemical machining. Electrochemical machining. ठीक है. What is the mechanism here? In electrochemical machining, the mechanism is ion displacement. Ion displacement. Okay, this is the mechanism in ECM. Please note it down because this is important from exam perspective. Please note it down. So these are the four headings. Okay. ECM में क्या रहता है? The ECM में it is ion displacement. It is ion displacement. And thermal में क्या होता है? Melting and vaporization. Melting and vaporization. Melting and vaporization. Due to thermal energy, it first melt and then it vaporize. When it vaporize, it creates a cavity over there. So don't you think these are the operations that can actually drill a hole for you? Don't you think these are the operations that can actually cut the work material for you? Don't you think so? Jaldi batao, don't you think so? Don't you think so? Yes, sir. Yes, sir. Yes, sir. I want yes from everyone out there. And please draw this mind map. Please draw this mind map. Then one by one we will start taking what? The operations. Quickly note it down. Quickly note it down. Quickly note it down. By the time I'll just come from washroom. Note down kar lo. Then we will start with electro discharge machining, which is a big topic. Electro discharge machining is a big topic. You note it down. I will be back from washroom. It will take 3-4 minutes. Yeah. Sorry guys, I'm back. I'm back. So let us start with the EDM process. कहाँ गया है? पानी वानी पी लिया जाए. अरे कुछ खाइएगा वाइएगा कि नहीं? चलो, so let us start with the electro discharge machining. Give the heading. First we will finish up thermal. Under thermal operation, first is electro discharge machining. Sir, now there are, please pay attention guys, ion beam machining. I means iron, ये वाला iron, ion beam machining, ion beam machining, ion beam machining. ठीक है, चलो. So now when it comes to gate exam, the numericals are asked. Now कहाँ से numerical they are asked? So this is a topic from where numerical can be asked. EDM is an operation from where numerical can be asked, and for PI people, that is the production engineering, and numerical can be asked from abrasive jet machining. These are the three areas from where you will be getting the numerical. Otherwise the whole operation is theoretical, but you will enjoy it. You will enjoy it. Is it clear? You will enjoy it. Chalo. So now let me start. So EDM is an operation जहां से numerical बनेगा. First try to understand what is EDM. First try to understand what is EDM. बहुत simple सी चीज है. Many people will say that this is the most complex operation, this and that. No. Sit back, relax, try to feel what electro discharge machining is. What? देखो. Suppose this is a workpiece and this is my tool. Suppose this is my tool. This is the shape of my tool. This is my tool. Please try to understand. Now, what will happen? In some time, slowly, like charging is there. Please see. Charging is there. And it suddenly discharges. So as soon as it discharges, it basically form a connection here. Okay, it's like a spark. It's like a spark. So spark goes and it machines this area. Yes or no? This white color area will be machined. Yes or no? This white color area will be machined. So whatever is the shape of the tool, the spark goes from all the complete surface of the tool, hit the workpiece, and machining will be done. And machining will be done. Yes or no? Yes or no? Do you understand that? How it is happening? What it is happening? I don't care. The process is of removal of material. The process is removal of material. How I am removing it? By spark. So slowly, after some time, if sparks are given, it will erode, or due to spark, erosion will take place, or you can say the melting will take place of the same shape like that of tool. Like that of tool. Yes or no? No, not like welding. Welding nahi hai abhi. Welding aayega. The non-traditional machining process is almost similar to welding. In there, we are using these operation to join the pieces. Here we are using the pieces to break the pieces. Is it clear? So processes are same. Electron beam machining, ion beam machining, you can say ion beam welding, electron beam welding, everything is same. But there the objective was to join two workpiece. Here the objective is to break two workpiece. Please be clear about that. Let us come back to the electro discharge machining. So when the spark gets initiated, the spark hit on the workpiece and machine the same area as the shape of tool. All of you agree? If you agree, please write in the comment section agreed, sir. If you agree, please write in the comment section agreed. Please write in the comment section agreed. Is it clear? Again, the charging will take place for some time. Zoo. Again, discharge happen. So spark in some time, you can say in a fixed interval of time, sparks are given by the tool. It melts the workpiece in the same shape and it evaporates. It evaporates. Now melting is taking place due to spark. Vaporization is taking place due to continuous spark. The temperature is rising. Due to that, the material will evaporate. The material will evaporate. And after machining, the workpiece look like this. The workpiece looks like this. The workpiece looks like this. Yes or no? So machining happened. Now let us check back certain things. Machining is done. Yes, sir, machining is done. Contact between tool and workpiece. No, sir, there was no contact between the tool and the workpiece. Now, complex shape can be made. Yes, sir, absolutely. Now you can give the shape to the tool. This is your electrode, or you can say the tool also. Now you can give any shape to this tool. Now you can give any shape to this tool. Yes or no? Now you are not giving actual shape to the workpiece. आपको hard workpiece को shape देने की जरूरत नहीं है. You are not giving the shape to the hard workpiece. You are giving the shape to the tool. Now tool will be made from low strength material so that you can easily give the shape. But due to spark, the same shape is replicated on the workpiece. So now don't you think that machining will happen? Don't you think machining will happen? कितने मजेदार चीज नहीं है? Don't you think it is so amazing that hard material is that I cannot machine it. So I take another material which is light. I give the shape to this. I put it as an electrode. It sparks. As soon as it sparks. Due to thermal energy, melting takes place, vaporization takes place, and I have given the same cavity on the hard work material. Yes or no? आएगा. नॉन कंडक्टर कैसे मशीन होंगे? नॉन कंडक्टर कैसे मशीन होंगे? I'll tell you, don't worry about that. I will tell you everything. Okay, you just need to make proper notes and feel the topic. So electro discharge machining is what? I am discharging the electricity at some fixed interval, which is nothing but in form of spark. Now this spark actually melt and vaporize the material, and hence our machining is done. Everybody understand how it will be done? That we will study. But the process is clear to all of you? The process is clear to all of you? Yes, sir. Process is clear. Chalo. If the process is clear, you need to understand this. Let us come back. So this is your tool. Suppose this is your tool. This is your workpiece. And now it is connected to the battery. If it is connected to the battery, a arc will be established. And it will start melting this area. Yes or no? An arc will be established and it will start melting this area. But I don't want this because this is a welding operation. It is this arc or this melting is not sufficient to vaporize it. This melting is not sufficient to vaporize it. So that is why ना 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 ना, ये वाला ऑपरेशन तो नहीं चाहिए मुझे. I don't want this operation. I want spark, that is all the energy at once, so that it melts and vaporizes. Vaporization is very important. Otherwise, if it melts and again gets solidified, what is the use of machining? What is the use of machining? What is the use of machining? So that is why you have to keep in mind. That is why what will happen? I need to supply all the energy at once. So what I will do? I will fix some capacitors here. I will fix some capacitors here. These capacitors are nothing. These capacitors are nothing but used to store energy. They are nothing but they are used to store energy. They are used to store energy. Now, in the first phase, please try to understand this thing. In the first phase, suppose this is V naught. Now the numerical concept is coming in. Theoretical I will tell you, but this numerical is a bit difficult because it is from the electrical background. Please pay attention. यार मुझे तो लगा था किंगफिशर चली गई यार, बम ऐड आने लगे वापस किंगफिशर के. Have you seen those ad? मस्त ऐड बनाते हैं यार ये लोग. Now, please pay attention. I have supplied, or you can say this is the voltage that I have applied. That is V naught. That is V naught. Okay. Now, out of, please try to understand it. Out of V naught, this is my V naught ka limit. This is my V naught. Now, this is my time. This is my time. So now, as soon as I switch on the battery, it will go up. It will go up because no current is passing, nothing is happening. Okay, it is just going up. That is this capacitors are charging. And as soon as they reaches a value, they reach up to a value, their limit is over. So suddenly they discharge, boom. Suddenly they discharge, like you used to have those cameras. In those cameras you have a flash button. You have like a flash. Okay, as soon as you press the button, light is thrown on you. Yes or no? When you click the camera, light is thrown on you. So that is why it is not that energy is supplied. No, energy is stored and all the energy is taken out at once within a fraction of second. That is the flash of light. Within the fraction of second, that is the flash of light. Is it clear? So that is why at this voltage, suppose this is the voltage VD, discharge voltage, it suddenly drops and within very few time it comes back to the original value. Is it clear? Yeah, just to show you, I have made this so, like you can say, wide, but this red line, straight line, and this is very close, very close. Is it clear? Now you can say that for time t1 it was charging, and for time t2 it discharged. Is it clear? For time t1 it was charging, and for time t2 it discharged. Is this thing clear to all of you? Everyone understood the concept? Everyone understood the concept? Jaldi batao, everyone understood the concept part, because it is important for you to understand the concept. जल्दी बताओ. ठीक है. नाउ यार मैं देख रहा हूं हर वीडियो में एक डिसलाइक करने के लिए बंदा जरूर आता है, कोई ना कोई. मतलब क्या डर रहे हो, कौन है, क्या दिक्कत है, बता दो. सो नाउ this is your discharging phase and this blue color one is your charging phase. Yes or no? This blue color one is your charging phase and red color one is your discharging phase. Is it clear? Now again it will go like this. It will again go like this, again comes back within very short period of time, again goes like this, again comes back with a very short period of time. Is it clear? So this cycle goes on, this cycle goes on, and at this point whole energy is released. At this point entire energy is released. At this point entire energy is released. At this point the entire energy is released. ठीक है? And flash or spark is given. At this point it directly makes it in this shape. Due to spark, this part gets melted. This part gets melted, and due to heat it evaporates, and yes, the machining is done. So now do you understand how it is done? Using capacitors. How it is done? Using capacitors. How it is done? Using capacitors. Is this thing clear to all of you? Is this thing clear to all of you? Yes or no? So now for the analysis part, let us move to the analysis part. You need to understand few things. Let us say R be the resistance of the circuit. This is RC circuit. Capacitance C. Here you are having the resistance R. So this is RC circuit. This is RC circuit. रेजिस्टेंस तो हर पार्ट में होता है. आरसी सर्किट तो लिखो रेजिस्टेंस ऑफ सर्किट इज इक्वल टू आर. रेजिस्टेंस ऑफ सर्किट इज इक्वल टू आर. सप्लाई वोल्टेज इज इक्वल टू वी नॉट. Discharge voltage is equal to Vd. Discharge voltage is Vd. C is the capacitance. C is the capacitance. Now, very important. What is the energy released? What is the energy released? Can anybody tell me कैपेसिटेंस के समय में क्या एनर्जी होती थी? हाफ सी वी स्क्वायर. हाफ सी वी स्क्वायर. हाफ सी वी स्क्वायर. Which voltage it is? Maximum energy that can be released is V naught square. If I am using V naught, that becomes the maximum energy, but it is not maximum energy. देखो, discharge voltage is less than your supply voltage. Yes or no? So that is why the relationship is fixed. This relationship comes from 12th class. ठीक है? That is 1 minus e to the power minus t divided by RC. Minus t divided by RC. Is it clear? Minus t divided by RC. Is this thing clear to all of you? Is this thing clear to all of you? जल्दी बताओ. ठीक है? That is depending on time Vd is decided. Depending on time Vd is decided. So this is first formula you should remember. This is the second formula that you should remember. ठीक है? Now this is obviously at discharge voltage. So I'll expand it. Half C V naught square 1 minus e to the power minus t divided by RC whole square. Now let us say t divided by RC की कुछ वैल्यू रख देते हैं. Let us say this is n. Let us say this is n. So can you say this value is equal to half C V naught square 1 minus e to the power minus n square. This is the value. This is the value, yes or no? This is the value. So this is the value of your energy. Now what is power? Power is energy per unit time. Power is energy per unit time. ठीक है? So what will happen? Half C V naught square 1 minus e to the power minus n का square. Is it clear to all of you? Is this thing clear to all of you? I don't think you would be having any doubt in this. ठीक है? Divided by t. Divided by t. Now I am multiplying r to the numerator and r to the denominator. Now this value can be written as what? ध्यान से देखो. What is this? What is this? What is this? Quickly tell me, what is this? Half V naught square 1 minus e to the power minus n square divided by Rn. This is your power. Now you actually need to maximize your power. Actually you need to maximize your power. Yes or no? So you simply do what? dp divided by किसके रिस्पेक्ट में करोगी? The only variable is n. dp by dn. Okay. Now you actually need to do this thing 0. When you will do this, you will get the value of n as करके देख रहे हैं. You want me to solve it for you? You want me to solve it for you? लिख लो यार, रिजल्ट ही लिख लो. 1.26. n का value is 1.26. This means that this value of n is 1.26. So can you write v2 1 minus e to the power minus 1.26? No. 1 upon 1 minus 1.26 e to the power minus 1.26. Can you see? Can you do that? What is this value coming out? What is this value coming out? 0.72 V naught. So for maximum power, the discharge voltage, यहाँ लिख लो, यहाँ मत लिखो. The discharge voltage is equal to 72% of the supply voltage. This is an important result. Please remember it. This is an important result. Please remember it up. Okay. The most of the question will be from the energy part only. But don't forget ki what is VD, what is V naught at maximum, for maximum power, what is the relationship between VD and V naught. Always remember this thing because this is important. Always remember it because it is important. Always remember it because it is important. Note it down. I have to connect the charger. Jaldi karo. Note it down. Now I will enter into the theoretical part. I will dictate. I hope that you will be writing. If you have not liked the video, please do like the video, guys. लिखो. The principle behind EDM. The principle behind EDM is based on erosion of metal due to spark. Is based on erosion of metal due to spark. What do you mean by video explanation? What do you mean by video explanation, Ashwin? Yeah, I hope that this is clear to all of you. बहुत ज़्यादा क्लियरिटी है यार जो भी मैंने अभी बताया उसमें. हाँ, so it is based on erosion of metal due to spark. Due to spark. since high amount of energy is required, in form of sparks, since high amount of energy is required for spark, capacitors are used to store energy. Capacitors are used to store energy and discharges and and all capacitor discharges together depending upon the energy amount of energy required. Depending upon the amount of energy required. Depending upon the amount of energy required. Depending on the amount of energy required. उसके बाद लिखो प्रिंसिपल. नेक्स्ट लिखो प्रिंसिपल. प्रिंसिपल. इसके बाद लिखो प्रिंसिपल. What is the principle behind? लिखो. The EDM process consists of a tool and the workpiece. The tool and the workpiece. The tool is given the required shape as it can be exactly replicated on the workpiece. The power supply given is DC. The power supply given is DC. The power supply given is DC. ठीक है भाई. The power supply given is DC. अब थोड़ा सा ध्यान से सुनो. Suppose I keep this whole assembly in a liquid. This is known as dielectric. Can anybody tell me what is the use of dielectric? And whether it is conducting in nature or not. Can anybody tell me what is the meaning, what is the use of dielectric? Can anybody tell me what is the use of dielectric and whether it is conducting or non-conducting? Whether it is conducting or non-conducting. Quickly tell me whether it is conducting or non-conducting. जल्दी से बताओ ये डाइलेक्ट्रिक का क्या कॉन्सेप्ट होगा. यूजुअली ऐसा ही होता है that there is a drum. ठीक है. inside this drum your dielectric is fluid, your dielectric is filled and we keep the entire setup inside. Do you know why? Because if this is your tool and this is your workpiece, now Now, if this non-conducting liquid is filled in between, why? So that arc is not formed. Otherwise, if arc forms, the capacitor will not be able to charge. The capacitor will not be able to charge. The capacitor will not be able to charge. So that is why we don't want the current to flow. We don't want current to flow. It charge up, charge up, charge up, charge up. When the potential difference becomes so high that it actually travels, that the electrons actually travels in form of spark, that is a very short duration of time when we are having the current is flowing. When the current is flowing, otherwise I don't want current. If current start flowing in the charging phase, the capacitor will not be able to charge. That is why we also use a dielectric material which is non-conducting in nature. Non-conducting in nature. Now do you understand that why non-conducting liquid is used? Because I don't want to establish an arc. अगर कंडक्टिंग होता होगा तो खटाखट से करंट पहले नहीं लगेगा. There is a gap, that is why current is not flowing. There is a gap due to which the current is not flowing. There is this gap now due to which the current was not flowing. Now if I fill some conducting material, the circuit will become complete and current starts flowing. Then where the energy will be stored? How the energy will be stored? How the energy will be stored? The energy will not be stored and there will be no spark. So for a spark, I am using this dielectric material which is non-conducting in nature. भाई ये क्या है? ये कौन सा नया टिकटॉक आया है? I challenge all the viewers. Ananthan Nair, why are you not challenging me? Am I different? Are you discriminating? Is this the way you should behave? Ananthan Nair, this is not good. I am not a viewer. You have not challenged me. It is really disappointing. चलो, हाँ, सो आगे लिखो. कहां तक लिखा था? डीसी पावर सप्लाई तक लिख लिया था. You have written till DC power supply, right? Now the assembly is placed inside dielectric. Now the assembly is placed inside dielectric. Now the assembly is placed inside dielectric, which is non-conducting in nature. Which is not conducting in nature. Which is non-conducting in nature. अरे इग्नोर तो करना ही नहीं है मुझे पता श्रेयस, मतलब आए हो तो पेलना है. Why should I Google it? Have anyone gave you contract that you want people to Google it up? दिहाड़ी डेली वेजेस पे काम कर रहे हैं क्या आप अनंतन नायर? कहाँ गेट 8 की क्लास में आ गए? I'll basically teach industrial and production. I'll basically teach industrial and production. Okay. So what we are discussing? अच्छा यार एक आध दो लोग होते ही हैं क्यों? Now मतलब डेली वेजेस पे 50 रुपीज अ डे पे 60 रुपीज अ डे पे आए, देन दे आर वेटिंग दैट वी विल एक्चुअली गूगल इट अप. दे सेड एंड वी विल गूगल इट अप. तो नाइस यार, सही है, करो करो करो. गेट के लिए पढ़ लिया होता तो ऐसा नहीं होता. क्या हम क्या लिख रहे थे? प्लीज 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 कंटिन्यू विथ योर नोट्स. ए कोई हंसेगा नहीं. नोबडी विल लाफ एट हिम. नोबडी विल लाफ. चलो चलो लिखो. प्लीज प्लीज राइट दैट you will place the entire assembly in the dielectric bracket, which is a non-conducting liquid. Which is a non-conducting liquid. Please don't troll the trolls here. Ayush, this is not a good habit. No. Don't do it. Nobody will laugh. We should motivate such employment. Employment opportunity should be motivated, na? चलो, when the potential difference between the tool and the workpiece, when the potential difference between the tool and the workpiece is sufficiently high, a transient spark discharges. A transient spark discharges through this fluid, through this dielectric fluid. Although it is non-conducting, but when the spark is having such a high strength that automatically the electron jumps from here to here. Automatically it happens, although the midway is filled with non-conducting liquid, but the strength and the power of spark, the energy in spark is so high that it automatically travels. This is what we want. This is what we want. Yes or no? When the potential difference oh, thank you so much. This is how the algorithm of YouTube works, right? Chalo, quickly. What I was doing, when the potential difference between the tool and the workpiece is sufficiently high, the transient spark discharges through the fluid. Now, capacitor discharges, energy is released, and the material is removed. The material is removed. अमित पनीग्रही, यू कैन ड्रॉप मी अ मैसेज ऑन व्हाट्सएप. यार अब इतनी बड़ी स्ट्रैटेजी अकेले में कैसे बताऊं? ये तो 1 to 1 वाली बात है ना. स्ट्रैटेजी है, प्लान बनाना पड़ेगा, एग्जीक्यूट करना पड़ेगा. चलो, नाउ वेरी वेरी इंपॉर्टेंट पार्ट. अरे यार, ये वही लोग हैं. मैं इतनी सुंदर हूँ, क्या करूं. ये सब वही लोग हैं, पता है. अरे यार, लाइव नहीं होता ना, सच कसा ही बता रहा हूँ. ऑफलाइन में कोई करके तो दिखा दे. लव कमेंट करें. पहले लोगों को बोलो 3rd क्लास से स्पेलिंग सीख के आए. स्पेलिंग ही नहीं लिख पा रहे. यार मजे ले रहे हैं. क्या नाम है श्रीमान का? बिल्कुल होता है ना. पकड़ लिए जाते हो, कचर के निकाला जाता है. चोरी करते हुए पकड़ गए, ऐसा सूत रहे हैं. बीटिंग यू लाइक एनीथिंग. लाइक these people are thrown out of the session. PNP, Shreyas, Gulab. PNP is like different ना यार. PNP, NPN, PNP बहुत कठिन था. सेमीकंडक्टर, it is like that only. It is actually like that. That is conducting. बीच में एक लेयर डाल दो so that direct conduction doesn't take place. That yes, this is that concept. This is that concept only. डिलीट भी हो गया. हाँ यार. चलो क्विकली, नाउ लेट अस मूव फॉरवर्ड. क्या लिख रहे थे यार? लिख तो लो पहले. बकवास कर रहे हो जब से. ठीक है. वोल्टेज, अब लिखो, वोल्टेज वेरीज बिटवीन 70 to 400 volts. Voltage varies between 1 voltage varies between 70 to 400 volts and the current ब्रैकेट में लिखिएगा ड्यूरिंग स्पार्क एंड द करंट ड्यूरिंग स्पार्क वेरीज बिटवीन 0.1 to 1000 एम्पियर. उसके बाद लिखो नाउ नेक्स्ट पॉइंट, द गैप बिटवीन द टूल एंड द वर्क पीस इज वेरी क्रिटिकल. The gap between the tool and the workpiece is very critical and it has to be maintained. For that, servo mechanism is used. For that, servo mechanism is used. For that, servo mechanism is used. क्लियर? लिखो आगे, नेक्स्ट पॉइंट लिखो. It can be used only for electrically conducting material. It can be used for electrically conducting material. क्या हो गया भाई? आयरन कार्बन डायग्राम इफ टाइम परमिट्स आई विल टीच यू, अदरवाइज मटेरियल साइंस वाली फैकल्टी ने पढ़ा दिया होगा ये, अदरवाइज आई विल टीच यू, नॉट अ वेरी बिग डील, आई विल टीच यू, डोंट वरी. अभी ये लिखो ईडीएम, क्या लिखा रहे थे? ईडीएम प्रोसेस can be used on any material that is electrically conducting. If electrically conductor नहीं होगा, how the spark will travel, how the electrons will travel, how the spark will initiate. So only for electrically conductive material. ठीक है, नो डाउट्स. लेट अस मूव फॉरवर्ड. इसके बाद लिखो इट सिंस EDM process does not involve mechanical energy, since it does not involve mechanical energy, hardness and other mechanical properties of workpiece does not cause hindrance in machining. Does not cause hindrance in machining. अच्छा, ये टूल काय का बनता है आपका यूजुअली? व्हाट इज द मटेरियल विद द हेल्प ऑफ विच योर टूल इज मेड? दिस इज ग्रेफाइट. इफ इन इंटरव्यू इट इज आस्क्ड व्हाट इज योर टूल मटेरियल, प्लीज डोंट फॉरगेट टू आंसर voltage varies between 70 to 400 volts usually. Is it clear? I hope that this thing is crystal clear to you, and every statement you can justify in your mind. You have felt the topic so good that you don't require any explanation. Whatever you are writing, you understand, yes, why you are writing it or how you are writing it and what is the need of writing. Is it clear? Chalo. Sometimes tungsten wire is also used. Sometimes tungsten wire is also used. Now give the heading dielectric. Dielectric. What is the use of dielectric? What is the use of dielectric? Quickly tell me, what is the use of dielectric? Because graphite is having high melting point. So although spark is generated, the graphite and tungsten, they do not melt. That is why graphite is used. Otherwise, if your tool melt, again you have to use new tool. Why to use new tool again and again? Why to use new tool again and again? Is it clear? So that is why we make the tool of high melting point material. Now, dielectric. The first use of dielectric, it helps. It helps to generate spark by not conducting electron through it. Electron को pass नहीं होने देता, and due to this the charging, this spark is generated because the capacitor is charged. Non-conduction, by non-conduction of electron through it. Second, it takes away the chip that is generated during machining. It takes away chip generated during machining. During machining. Clear? Third, it increases material removal rate. It increases material removal rate. It increases material removal rate by forming और by, यार स्पार्क फॉर्म होता है ना, अगर स्पार्क नहीं होगा तो इतना ज्यादा मटेरियल रिमूवल रेट नहीं होगा, तो इसको कैसे लिखोगे? इट इंक्रीजेस मटेरियल रिमूवल रेट बाय हेल्पिंग इन फॉर्मेशन ऑफ स्पार्क Is it clear? Now, if voltage increases, it might become conducting. That is the property, that if you apply the potential difference and if you start going on, it goes on increasing the potential difference, then it actually becomes conducting. So that is why we keep it as at low voltage and low current, so that it should not be conducting. Low voltage or low current. Is it clear? The mechanism is melting and evaporation. ये सारी चीजें हो चुकी हैं. देखो, एक स्टार मार्क करके चीज लिख लो. Please mark star and note down. When spark hit the workpiece, a crater will be produced over it. A crater will be produced over it. A crater is produced over it. ठीक है. इसके बाद एक चीज लिखो. We add some amount of copper. We add चिप नहीं है, इट इज नॉट चिप, इट इज लाइक द डेब्रिस, जो बचा कुचा माल रहता है ना, इट इज लाइक दैट. Okay, these are not chip, it is like the leftover part, they are not exact chip, they are the leftover part of machining. Okay, some amount is evaporated, some amount dispersed here and there. So the amount that is dispersed here and there, I am talking about that. Now some amount of copper is added to the graphite tool. Some amount of copper is added to the graphite tool to increase its conductivity. Strength देने के लिए नहीं होता है. Please remember, you people will ask, oh, to give strength to the tool, otherwise it should not melt. No, I am adding copper to the workpiece. I am adding copper to the workpiece just and just because of one reason. That is what? To make it more electrically conducting. Electrically conducting. तो लिखो copper is added. Copper is added. Copper is added to the graphite to increase the conductivity. To increase the conductivity. ठीक है. चलो ये सब तो हो गया. आई डोंट थिंक दिस इज अ इशू टू यू. दिस थिंग इज क्रिस्टल क्लियर टू यू. ईडीएम प्रोसेस में कोई डाउट हो तो पूछ लो. इफ यू आर हैविंग एनी डाउट इन ईडीएम प्रोसेस, प्लीज लेट मी नो. If you have any doubt, please let me know, otherwise I will solve a question. I will give you a question to solve. चलो. Resistance of a circuit is given as 40 ohm. Capacitance is given as 20 microfarad. Don't forget to change the unit. Supply voltage, supply, that is V naught, is 220 volt. Is 220 volt. Discharge voltage VD is equal to 110 volt. 110 volt. Okay. In an EDM process, a 12 mm diameter wire hole is made. A 12 mm wire diameter hole is made in a plate of thickness 50 mm. In a plate of thickness 50 mm using graphite tool and kerosene as dielectric. Using graphite tool, you can. ठीक है. Now, using graphite tool and kerosene as dielectric, calculate the time for one cycle. Time for one cycle. This is question number 1. And what is average power input? What is average power input? ठीक है, आपको टाइम निकालना है. यू हैव टू कैलकुलेट ना. T1 यहाँ पे क्या होता है? T1 इज द चार्जिंग फेज. जल्दी निकालो. सिंपल है, वेरी वेरी सिंपल. You all know the relationship between VD and V naught. Apply the value and get me the answer. Quickly answer this question, you can solve. Quickly solve, I am giving you 5 minutes. Take your time, solve, and I am expecting some answer. I'll bring my water bottle. By the time I request that you should answer the question. 5 minutes hai. Very simple question. Very simple question. Average power is energy divided by charging time T1. Guys, why you are not answering? दिक्कत क्या है? Calculate time for one cycle. You all know VD is equal to V naught 1 minus e to the power minus t by RC. Yes or no? You have to find this time only, na? You have to find this time only. VD is given as 110. Voltage is supply voltage is 220. 1 minus e to the power minus t divided by. क्या एक आंसर दो? 0.554. 0.55 millisecond is the right answer. 0.55 millisecond is the right answer. Very good. ठीक है. Many people have answered it. Very good. Good. Now please see the solution. Resistance is what? 40 ohm. What is the value of capacitance? 20 microfarad. 20 into 10 to the power minus 6 farad. Yes or no? Yes or no? You simply solve it up. 0.5 is equal to 1 minus e to the power minus t divided by 40, 80, 800, 0.0008. This is the answer. This is the part. ठीक है. E to the power minus t divided by 0.0008 is equal to 0.5. Now t divided by minus t divided by 0.0008 is equal to log of 0.5. This is nothing but minus 0.69, and when you will multiply, the time comes out to be what? 0.556 seconds. 0.555 second millisecond. 555 millisecond. पॉइंट के बाद भी मिलीसेकेंड है, एंड दिस इज योर आंसर टू द फर्स्ट क्वेश्चन. ठीक है, अब कितना सिंपल था. नाउ आई कैन नॉट टेल यू मोर देन दिस यार. व्हेन यू प्रैक्टिस क्वेश्चन देन ओनली यू विल कम टू नो. ठीक है, चलो. द सेकंड थिंग दे हैव आस्क्ड इज एवरेज पावर. Average power, half CVD square divided by T. This is what you require. Half 20 into 10 to the power minus 6 into VD is 100 as 10 square divided by time is what? 0.555 into 10 to the power minus 3 seconds. And when you will solve it up, 3 get cancelled, minus 3 and 3 get cancelled, 2 get cancelled. ठीक है, 11 121. ठीक है, when you will solve it, you will get it as 218 watt, or you can say 0.218 kilowatt. Now this is the easy level. कोई इससे ज्यादा टफ नहीं है, नथिंग, कुछ भी नहीं है इसमें. This is actually not having anything. This is not having anything. ठीक है, ये चीज आपको पता होनी चाहिए. This is very simple question from dielectric, or from, you can say, this particular part. चलो, so from here I'll end my topic. ये लिख लो. चलो, application advantages, disadvantages, हाँ लिख लो. चलो, write advantages and disadvantages also for EDM. First advantage, material removal rate is comparatively very high. Material removal rate is comparatively very high. Second, the degree of finish is also very good. Third, complex shape can be easily made using tool. Complex shape can be easily made using tool. Disadvantage, write down disadvantage. Wearing of tool is also very high. You can say wear rate of tool is also very high. अब spark निकलेगी तो obviously melt तो होगा ना. So wear rate of tool is very high. Wear rate of tool is very high. Only electrical conducting material can be machined. Only electrical conducting material can be machined. Only electrically conducting material can be machined. And third, the accuracy is quite difficult in EDM. Reaching accuracy is quite difficult in EDM. ठीक है, एप्लीकेशन लिख लो. It is used for making designer shapes, slots inside the diesel fuel injection nozzle. Slot inside the diesel fuel injection nozzle. Also used to make blind cavities. चलो, so this is the part. I am done for the day. आज के लिए काफी लंबा हो चुका है. Thank you guys. Hope to see you soon. 10 minutes I am there live today. ठीक है? Please ask doubts. प्लीज आस्क डाउट्स. ठीक है, यहाँ पे मेरा ईडीएम प्रोसेस खत्म हो गया. अब डाउट्स पूछ लो, फटाफट डाउट्स पूछ लो. आई विल वेट फॉर 5 minutes. If nobody will respond, if no one is having any doubt, I will move forward and close this lecture. Quickly do it up. Quickly, if you have not liked the video, please do like the video. If you have not liked the video, please do like the video. होलोग्राफ में बता दूंगा आपको नेक्स्ट क्लास में. Actually, quickly, if you have not liked the video, please do like the video. If you have not liked the video, please do like the video. How actually it is made. Power plant is taken by, you can say, this Sandeep sir is taking. Sandeep sir is taking power plant. You can watch his lecture. होलोग्राफ में बता दूंगा आपको नेक्स्ट क्लास में. Actually, quickly, if you have not liked the video, please do like the video. If you have not liked the video, please do like the video. How actually it is made. Power plant is taken by, you can say, this Sandeep sir is taking. Sandeep sir is taking power plant. You can watch his lecture. I think we are done. Hologram doubt बता दूंगा आपको next class. Still there for 5 minutes. Actually, quickly, if you have not liked the video, please do like the video. If you have not liked the video, please do like the video. How actually it is made. Power plant is taken by, you can say, this tomorrow we Sandeep sir is taking electrochemical. Sandeep sir is taking power plant. You can watch electrochemical machining. It is also having a lot of questions and similar kind of questions are asked from electrochemical. Hologram doubt बता दूंगा आपको next class. Still there for 5 minutes. Actually, quickly, if you have not liked the video, please do like the video. Watching the video, hope you have enjoyed the lecture. You don't have any doubts, so I can also close the lecture. Let us meet by 6 p.m. because 6 p.m. we are starting with the industrial chemical machining. This is the first class having with electrochemical machining. It is also having a lot of questions possible and similar kind of questions are asked from electrochemical. Hologram doubt बता दूंगा. If it is possible, please send the message in your college group as well that yes, we are going to start with a very important topic, that is industrial revision. It needs not that you should solve the question or you should have studied industrial earlier. Although you should have studied that, you should not wait for last moment. But now you cannot go with each and every subject. So for my subject, I have decided I will give you the revision module. You don't have to worry about anything. Okay, most probably, I cannot assure you anything, but yes, most probably all the question will be from the notes, my notes. ठीक है, चलो. Thank you guys for watching the video. Hope you have enjoyed the lecture.